Thanks to Creality for sending me this Creality Scan Sermoon S1 laser and infrared scanner for review. The silicon case, it looks quite similar to the Laptop Pro. It's the same size for the case. The same cable as the Laptop Pro. It's the same 12 volt, 2 amps. Under here should be the calibration board. It's the same size as the Laptop Pro. This calibration board. This is the Sermoon S1. It priced between the Laptop X and the Laptop Pro. So what are the differences between all these three 3D scanner? The Laptop series, Laptop Pro and Laptop X share the same depth camera. This depth camera is the same. It shares the same 7-line laser module. But for the Laptop Pro and the Laptop X, it uses different cross-line projectors. The Laptop Pro has 24 lines, and the Laptop X has 34 lines. The capture length is wider. So the cross-line from the Laptop X is 30% faster than the cross-line from the Laptop Pro. And what about the Sermoon S1? The Sermoon S1 has all new depth camera, so the camera here is different module from the camera in the Laptop series. It has lower resolution than the Laptop series. Yes, you heard that right. This one is 2.3 megapixels and this one is 2 megapixels depth camera. What about the projectors? The projectors in the Sermoon S is all new. 7 lines is a new module. 34 lines, it uses different module than the Laptop X. And for the single line, it's a new projector from Creality that used for scanning a deep pocket. So what else is different between the Laptops and the Sermoon series? For the Laptop, it has infrared that you can use for scanning without the markers. It has only one pair of the camera, so it uses this same camera for both blue laser and infrared mode. But Sermoon S1 is special. It has a dedicated, large field of view depth camera for the infrared mode. This one, see here? And you can also use the depth camera for the blue laser for scanning in the infrared mode as well. This depth camera will only work in the large mode, so it has a very large field of view. And this was taken from the Otter Lite. If you've seen my video on the Otter Lite review, you will see that the Otter Lite has a very good tracking performance on the larger depth camera. And now the Creality put this same module from the Otter Lite into the Sermoon S1. This thing costs like $700 US. So does it work with the Wi-Fi handle that you are using with the laptops and the Otter? Yes, it does work, but not yet because they need a firmware update for this. And by the time that I'm shooting this video, the release has not been pushed out yet, so I cannot test the wireless handle in this video. And the software that I'm going to use to test this Sermoon S1 is the beta version. This is a pre-launching products, and they sent it to me for testing before they actually finish the software. The final software should arrive when the first customer receives this product, which is early of the August. First, I will test the marker spacing for the Sermoon S1 in the parallel line. This 4 marker has 6 centimeters of spacing. 6 centimeters works. 8 centimeters is still working. So this is wider than the Laptop series. I don't think 9 would work. Let me try. 9 centimeters is still working. This is 10 centimeters marking space. 11 centimeters. No, 11 centimeters is not working. Okay, I'm going to move to the cross line mode. It's 10 by 10. Oh, you see that? The 34 lines projection range is very wide. Okay, so 10 is working. Okay, now it's 12 by 12. Yeah, 12 is working. Yeah, 14 still working. Yeah, 15. 16 is still working. 17 still working. 21 is still working. 22. Yeah, I think 21 will be the limit. And for the single line, I put the spacing here is 20 by 20. In the single line mode, it also has the same marker spacing as the 34 lines. Okay, next I'm going to measure the working distance from the object. It's 34 centimeters, so it's about the same as the Raptor X and the Raptor Pro and the Raptor series. Parallel lines, yes, it is the same, 22 centimeters. So the working distance from the object, the parallel line is the same as the Raptor. Okay, next I'm going to do a speed test with a 7 line. I'm going to do the global marker. So it's track smoother if you add more marker. I can see that the flame rate is 90. Okay, next I'm going to do the same scan with a 34 line. Okay, let's me do white cloud scanning. Cross line 0.3 millimeter. What makes a good 3D scanner for reverse engineering? Number one is the precision. Precision is the ability for the 3D scanner to scan the same object and get the same result. Just like the other scanner that I test, I'm going to scan this with an egg in 3 orientation. So there are going to be 3 scans, this orientation, this orientation, and this orientation. And then I'm going to merge these 3 scans together. The egg is not a round object. It has a discrepancy about 50 microns. That's what the nature made this egg. 50 microns out of roundness. So if the software can merge these 3 scans together, it means that the scanner can detect the differences of the variation under 50 microns, and after I measure it, I won't be able to see the seam line when it merged this scan together. So egg is the simplest object that you can use for testing for the precision of the 3D scanner. Okay, next I'm going to merge it together. Click on here, auto alignment. Okay, so it can merge automatically. On the left is the Raptor S1, and here is the Metro X. It has a seam line. You can see here that the 2 scans has different size, but S1 and the Raptor's Mark III is fine. The Moses also show no seam line. Okay, so the second most important thing for the 3D scanner is the resolution, the ability to capture detail, small details from object. So if the 3D scanner has a higher resolution, it can scan the intricate detail. For the resolution, it comes directly from the projector, that's one, and also the camera. The camera from the Raptor series has 15% higher resolution than the Sermoon series. So 2.3 megapixels, 2 megapixels for the depth camera. And I'm going to compare it with this. I'm going to use the 0.1 millimeter for the resolution. Okay, I'm going to fuse it 0.1 millimeter. Scan 4 and 5. Click on aligned. Let's exit here. I will turn off. It was a clay that I used for supporting. I didn't delete it. Okay, so here's a result from the Sermoon S1. Okay, here's the result. I rescanned the Raptor with a 0.1 millimeter resolution. In my previous video, it was scanned with a 0.15 millimeter because it takes very long time to scan with a 0.1 millimeter. So I use 0.15, but when I scan with the 0.1, the Raptor give the same result as the Math tree, as good as the Math tree. The Otter was 0.15 because that's the highest that the Otter can do in a small mode, and the Otter Lite is worse than the Otter. And the Waker is now fall behind the Raptor because when the Raptor is scanned with the 0.1 millimeter, it gives a very high resolution. But for the S1, it gives the same. I think it's quite close, even though the depth camera from the S1 is lower of the resolution. But the end result is very, it's the same as the Raptor. Can you see difference? The Metro X in the 7 lines. A blue laser, the detail is quite different. Okay, let's take a look in the back side. Okay, Math tree, Raptors and S1, it gives a very similar result. The eggshell of the Math tree is the smoothest, and the Raptor is rougher, and S1 is even rougher than the Raptor. I have already decreased the brightness of the laser line to manually. It still shows the striking line. This is usually come from of the overexposure of the laser line. I think they have to do some fine tuning for the S1. I hope that they can fix this before the final release of the software. From what I see here, the definition of the scan is very good for the S1. I cannot tell difference between the Raptor and the S1. I think the Math tree give a higher resolution. I can see from here. Okay, next I'm going to scan this fairy with a 0.3 millimeter resolution in a cross-line laser mode to see the detail and compare it with the cross line from the Raptor X. Okay, this is 0.3 millimeters, and this is 0.2. So it has twice the number of the point cloud between 0.3 and 0.2. Sometimes you get more point cloud, it doesn't mean that you have more detail from the object. Adapter Pro and Adapter X was scanned in cross line mode, 22 lines and 34 lines. They are both scanned at the 0.3mm resolution. Adapter X and Adapter Pro gives the same, exactly same detail. S1, same resolution, 0.3mm. Adapter Cross Laser and the S1 Cross Laser gives the same detail. Between S1, 0.3mm resolution and 0.2mm, I don't see any difference. So if you scan with the 0.3mm or 0.2, you get the same result, but with the 0.2, there's going to be more point cloud, but the detail doesn't show. So it takes longer time to scan. And 50.16. Okay, here's the result from the cross lines, and this will be the result from the parallel lines. I will export this and measure it in the cloud compare. Cross line leads 150.138 and the parallel line leads 150.112. The reading from my vernier caliper is 150.16. For the parallel lines, the accuracy error is 48 microns, and for the cross line, the accuracy error is 22 microns. Okay, this aluminum bar is 2 meters in the length, and I have been measured and confirmed with the lighter, and I have already applied a marker sticker on here. So I'm going to test the drifting error from one end to the other, 2 meters, how far it will drift away. I'm going to scan for the global marker. Okay, here's a value for 2 meters is drift away 147 microns, so it's about 75 microns per meter. Global marker, import, point cloud, cross line. Okay, this time I'm going to use automatic exposure. Okay, so capture black color quickly, no issue. Okay, I'll switch to a single line to scan the gap in the bottom area. and this area, and this area. Make a second scan. Final one. Six, 7, and 8. Okay, here's a comparison. Raptor Pro and the S1. You can see here detail on the jack for the Raptor Pro is noisier than the one from the S1. But S1 is a bit of a cheating. It was scanned in 3 modes. 34 lines, 7 lines, and a single line. So along the edge here, it was scanned with a 7 line, even though it's the same 0.3 millimeter resolution, but it gives a finer, smoother surface. Okay, if you look from the battery here, the Raptor Pro has some noise, but for the detail, I think it's the same with the single line laser. You can see here, the Raptor Pro doesn't have single line laser. So software fill the pocket here with the mesh. But with the S1, I use single line to scan deeper. With the single line, it can scan deeper into the pocket. But the Raptor Pro, it fill in with the mesh instead. And you can see it from this angle as well. This one go deeper because I use single line. A lot of time you will run into this issue when you have an object that has a narrow opening and deep. So you have a lot of dimension in here. Deeper inside, you have a fillet. You have a taper inside of here. So you're gonna need a single line laser to do this because the camera of the scanner will concentrate on just a single line of the laser, and it has a special projection that it can scan the size of the hole like this. Before this, I saw someone, they put a silicone, they cast a silicone inside, pull out and scan the silicone, but that give a lot of error. This time the Sermoon S1, it has a single line laser projector. So let's see how it performs in such a deep pocket like this. But before I start, this part is very reflective. The 3D scanner doesn't like reflection. So the part is spray. I put it right here in the center of the turntable. I scan bottom part first and then I flip it up to scan the other side. And I used the 7 line to scan around this object. After that, I switch to the single line. I choose 0.15 for the resolution. Okay, next I'm going to switch to the single line. If you lean it a little bit, you can scan side of the wall. In this case, it has a notches, it has a fillet and taper. I do the best I can to get to see how the single line gets into the hole. But the hole on the other side is larger, so I will show you more on that side. Okay, I will start with the same parallel lines, 0.15. Okay, I'm done with the outside. Next, I'm going to switch to the single line. You can see this, but I'm trying to scan the side of the hole. So I lean the 3D scanner on one side. Very slowly. Move it. Can you see it? Yeah, it's go like very deep inside. See that? That's how deep it goes. Uh, 0.15 millimeter. Okay, next I'm going to merge these two parts together. 1, 1, 2, 2, and here 3. Let's see if it can align this. Yeah, it can align this. It's unbelievable. And then I'm going to measure it. Okay, so let's export this and check for the scan quality. The sidewall socket is quite smooth. I can clearly see the fillet here, but the bottom of the hole is a rough surface, different from the sidewall of the holes. Sidewall of the hole is very smooth. Okay, let me flip to the other side. Okay, next I'm going to make a 3D scan of this plastic car part. The part that I often encounter when the customer want me to reproduce the part. Part like this is contains so many pockets. As you can see, it's created by using the lips, and sometimes you don't want to do a reverse engineering, but you need to make a complete scan. So all the edges at the bottom of the pocket has to be scanned 100%. There can't be any unscanned data. If you scan with the 7-line laser, you can't get all of this bottom of the pocket scan. You need to use the single lines. So I switch between 7 and single lines during the scan, and point cloud use parallel lines 0.15 mm for the resolution, and I will use automatic exposure. I'm switching to the single line. So I flip this over. There is no missing point in the corners anywhere. Merge these two scans together. 1, 2. So I just need an approximate location. And 3. Align. Okay, so the part is aligned. I'm going to mesh it to 1 million point. Okay, so here's a mesh part, 1 million faces. So the scanner scan all of the blind spot, so there is no point where the software recreate the mesh by itself. So you get pretty much correct data. Yes, this is kind of the part that you can print without doing the reverse engineering because it's all scanned at 100%. Okay, next I'm going to go downstairs and scan a scooter and a car. So I need to use my laptop, and the Wi-Fi handle is not working right now because they haven't released the full software version yet. So I need to power this 3D scanner with a 12 volt 2 amps. So I'm going to use this power bank, connect it to USB-C to a 5.5mm DC jack, plug it into my laptop. If you have a budget, get a Wi-Fi handle. Then scan for the global marker. I have a 90 frames per second with the laptop on the batteries. I go up here. Have about 50 frames per second on the batteries. Okay, here's the car panel comparison. Raptor Pro and Raptor X, and it is the same for the Sermoon S1. It gives the same detail, smoothness, and resolution. Because this is a beta version and they have issue with the automatic exposure. I can see that when I turn myself against the light and the scanner is trying to adjust itself several times. Unlike the Raptors, they don't have this issue with the automatic exposure. You can just turn automatic exposure on and start scanning. In the infrared mode, you can choose between two depth camera. the larger FOV depth camera that's migrate from the Otter Lite, and the high precision depth camera that used for scanning in the blue laser mode. To activate the larger FOV depth camera, you need to click on the large mode, and you will have an option to select between the standard, which is the high precision depth camera, and the wide angle, which is the Otter Lite depth camera. Medium object, the larger depth camera option will be disabled. So with the medium and small size, you need to use the standard depth camera, which is the same one that used for scanning in blue laser mode. Okay, so it's a helmet. You can see from the preview windows. So it's a medium object, about 25 or 30 centimeters. Okay, so if you don't need high precision, okay, so it's done. It's faster than the blue laser. Okay, it's gonna take a longer time than the infrared, but you can see the result there. So I don't put the markers on the object itself. Okay, let's compare. On the left is from the infrared. On the right is from the cross-line laser. You can see that the cross-line laser has a smoother surface. And when you see all the corners, on the corners it's sharper. You can see this corner is sharper than the one from the infrared. So when I do reverse engineering, I would prefer smooth and clean point cloud than the one with the less sharp. It will be more difficult for you to tracing. Okay, so I will scan with the infrared mode in the large object size geometry. Yeah, I can confirm that it scans like the Otter Lite. I'm scanning the card panel without using the marker. Large mode NIR using the large FOV camera is same quality as the Otter Lite that I review in the infrared mode, large FOV camera, which is the same one as the Otter Lite. And it was scanned without using any markers. So the furthest I can scan in a good quality is about here. Because the passenger door is flat, so if I continue to scan, it will start to lose the track. When you see like this, it looks like it is a good quality scan, but in fact it has a lower precision, so you don't want to design anything over this scan. It's not going to fit the real car. It's the nature of the infrared scan. Okay, so in conclusion, I've been testing this Sermoon S1 for 30 hours straight in the past 3 days. Okay, one for the precision, as it is the most important quality of the 3D scanner. The S1 has the high precision, same as the Raptor series. When I cut a thin cross-section of the point cloud from the blue laser scanning, it's very thin, I mean 4 to 10 microns thickness. Okay, 2, for the resolution, the S1 comes with the lower resolution camera for the blue laser. It's only 2 megapixels and this one is 2.3. And when I compare the model, the R model, it gives the same level of the detail. Okay, 3, the accuracy. I test with the aluminum block. Dimension accuracy is about the same as the Raptors in the blue laser mode. The speed from the S1 is faster when it's connected with the cable. And for the reliability, I plug it on 12 hours a day in the past 2 days and scan everything that I need to test, and I haven't found any issue with the hardware yet. The projectors in the cross line project constantly left and right all the time. No issue with the projectors, no issue with the heating. So what I like the most about the additional feature, spacing for the markers. This one is 10. I measure this one 21 centimeters, but Creality said 15 will be optimum distance for the markers. Number 2, it has a single line. This is very important. Single line laser. In reality, you are going to run into the object with a lot of crevices and deep gap. That's the fact, and you won't be able to make a complete scan. So you will leave something over. There are going to be a lot of blind spot. But with a single line laser, it can scan side walls and the bottom of the pocket. So it won't leave any blind spot. Last year, I heard a lot of people asking why don't they put the Otter infrared into the Raptors. Now they actually do that. Okay, so here's my thoughts on the first review of the Sermoon S, the beta version. Thanks you guys for watching. I'll see you in the next video.